Hey, good morning, Chem 1110. Uh, just had a few topics that I wanted to discuss for Monday, August 24th. We're going to have our first bonus quiz. Now, the bonus quiz is simply a quiz dealing with topics in our video lectures. In this way, it gives me a way to encourage you to watch the videos. This quiz will involve dimensional analysis, which is a topic that we're going to finish with today. I prepared a checklist of things that we need to think about when we conduct dimensional analysis. Checklist, things we need to check for. We need to check that, make sure that our units that we're using are correct. We're going to find conversion factors that we're going to be needing in the problem to help us convert from one unit to another unit in some cases. And things that we need to remember, that the given units in our conversion factor are in the denominator, and then units that we desire at the end in terms of our answer, those are going to be in the numerator. So there's our checklist, and there's how we solve problems using dimensional analysis. We're going to go through a problem now that I have posted on today's PowerPoint. So today's problem involves converting from cubic centimeters to cubic meters. So let's first of all write down given in this problem. So what's given in the problem is 1.5 cubic centimeters, and what we want to do is convert it into cubic meters. So let's write down some things that we know, some conversion factors that we're going to be using to help us solve this problem. Well, what we know, and two ways we can write this. Again, these are equivalent ways of representing how the centimeter is related to the meter. 1 centimeter is also defined by 10 to the negative second meters. Or another way we could write this, an equivalent way, is 100 centimeters is equal to 1 meter. So either of these conversion factors can be used to help us solve this problem. Now, the problem here that makes it a little more difficult is that our units are cubed. These are oftentimes the cases that we're going to be used in terms of volume conversions. So if the units are going to be cubed, then so do the conversion numerical values for these conversion factors also have to be cubed. So let's work on the problem now. Let's set up our problem using just our method of conversion factors. Remember, what we're given is 1.5 cubic centimeters. And let's use the conversion factor up here and how we're relating centimeters to the meter. I'm going to choose this one. We could choose either one. Either one is proper. So let's use our conversion factor. We multiply by a conversion factor in which the units that are given, in this case, it's centimeters and they're cubed. Those are going to be in the denominator. So this is 100 centimeters. And remember, it's cubed. So let's put these in parentheses, because not only do we have to cube the unit, but we're going to cube that value of 100 also. And let's put our desired unit in the numerator here, 1 meter. And that's going to be cubed also. We're going to put this into our calculator, and we're going to get an answer for this, 1.5 times 10 to the negative 6th cubic meters. Our original piece of data had 2 significant figures. Our answer has 2 significant figures. So that's how we can do conversions involving exponents. In this case, it's similar to what we would do for a volume when we're cubing a length. So this is how we solve that type of problem. Thanks. We'll go through part 3 in a few minutes.